Hi folks, I am Satyam and in this video I am going to tell you about MooseStack. MooseStack is an open source framework developed by 514 to improve your developer experience while working on analytical system. They also let you ship your analytical system as code. But what is the current problem with a analytical system? There are generally two type of applications or features and each require different kind of architecture. One with the most classical user experience require transactional operations that handle your day-to-day business activities like order processing, payments, inventory management, and all. The important thing here is that they're optimized for CRUD operations and they're built for transactional workload. Usually, they tend to have a very good developer experience because of the tool around that. But the one that we are mostly interested in is OLAP systems. They are built for analytical processing. They handle complex queries and aggregations on large data sets. They're even capable of processing billions of rows efficiently. They use columnar DBs for better compression and query performance for analytics, and they focus on query speed over write performance. Everything is fine until here, but then the problem arrives with the OLAP. The problem with the OLAP is setting up and managing it is very difficult. It's a painful process because it contains complex stack. It brings together multiple tools with having different types of configurations, and most of the tools do not run locally. They do not even provide support with the ID, and they lack version control. Everything that is required for a developer, for a natural dev workflow, it lacks that, and making the experience very poor for a developer. To help you understand more about how an OLAP system is set, there is a blog by Red Panda that tells you how to build an OLAP database with ClickHouse and Red Panda. And the part that I am mostly interested in showing you is this step-by-step part. To set up the OLAP backend, these are the steps that you need to follow, and that involves like spinning up a Docker container with Red Panda cluster, and then spinning up a Docker container again with ClickHouse, and then creating topic within Red Panda, and creating database, configuring your Red Panda to your ClickHouse, feeding the data into your ClickHouse from Red Panda, and creating materialized view, and then running SQL queries on top of that. The point that I'm trying to make here is these are only two tools, and as you can see, it has already got 7 to 8 steps involved. Now imagine a complex system that required different tools. Different tools would require different configurations, and that leads to big challenges. Let me walk you through the challenges. Yeah, so the challenges are specifically time consuming. You need to do the redundant work. It is very hard to manage at a scale, and it increases overall your operational complexity between the tools, and more the tools, more the failure points. So this is where Moose comes to help you. Moose brings you the code-first approach to build your OLAP systems. Moose is a framework that brings you all the power of OLAP stack, but without its operational complexity. Using the code-first approach, let's see what Moose has to offer to build our OLAP systems. When building your system with Moose, you no need to wire your tools. MooseStack automatically spins up and manages your OLAP infrastructure. When your Moose server is running, it automatically spins up Docker container for ClickHouse, Red Panda, and Temporal. It is not similar to the one in the blog where we spun up the Docker containers manually, and you even do not need to connect these tools with each other. So no configuration needed, and also it provides templates to set things up very quickly. So Moose makes things very easier for you while setting up the infra, and it automates everything in code from streaming to workflows. If you want to define your schemas, you can define in code. If you want to define your materialized view, you can define in code. Streams, you can define in code. APIs, you can define in code, and it also wires them all together with code. So imagine how happy a developer would be looking at this kind of system rather than configuring multiple tools together. It is even easier to debug because everything is code over here. Improving the developer experience with the code-first infrastructure, you get the local development, you get the hot reload, instantly update your code, and you do not even need to restart the server to reflect the changes, and you have got seamless integration with GitHub Actions, GitLab CI, or any pipelines, and you have got version control to track the changes and collaborate effectively with your team. And here comes the most beautiful part of the MooseStack. MooseStack has an agent harness. It sits between your OLAP stack and your AI agent, and it gives the whole context interfaces, code, and skills to your general AI agent. Now, with the help of AI agent, you do not need to optimize your data models and queries manually for OLAP and handle the schema changes and migrations. You can ask AI to build real-time streaming pipelines for you and connect analytics to the front-end applications. It's very easy with the MooseStack to let your AI agents connect with your OLAP stack and get things done. So the conclusion over here is that Moose simplifies your OLAP systems. It simplifies the developer experience of building your OLAP system. It reduces your operational complexity by automatically managing your tools and spinning them up, and it improves your developer experience, providing you local development, hot reload, and CI/CD integration. And it provides you the AI integration where AI agents can query your data, inspect logs, explore infra, and help you with debugging. So to summarize, MooseStack makes OLAP development as simple as building a web application. No need to juggle between tools and wiring the multiple tools together. Avoid all the complexity. You can use simply Moose and everything is handled in code. It is very easier to debug. So this was all about Moose and the problems that we face specifically with the OLAP system. Now let's get to the demo to see how Moose works practically. I built a application real-time flight dashboard using Mood, where it tells me about how many flights are currently in the sky now and what is the average velocity trend. So all of these things I built using MooseStack only. Let's get to the GitHub. So the application that I built over here is real-time flight tracking and analytics using MooseStack. It ingests the live data from OpenSky network. I'm using the API for that, and it stores in the ClickHouse, and it serves the data through APIs to the dashboard, and it has got materialized views, scheduled workflows, and chat interface. It includes a very beautiful Next.js dashboard. Let me take you to the dashboard over here. So this is the dashboard. It looks very beautiful, and it tells you about a unique aircraft, the number of unique aircrafts and active regions. You have got hourly traffic over here, and you have got altitude distribution that gives you the average and maximum barometric altitude of flights over time, and then you have got velocity trends that gives you ground speed analytics with respect to time, and you have got origin countries of the flights, like the countries with the most registration of aircrafts. So this is how the dashboard looks like. Now let's see how the data is getting seeded into this dashboard and how I built the application using MooseStack. For that, you can clone my repo from here. I have already cloned it, so I have this running. I have this in my computer locally. So let me open this in the cursor. My bad. So yeah, this is the scaffolding of the application that I have, and you can use Moose templates to scaffold your application. If you, after installing the Moose CLI, if you simply run the Moose template list, it will list down all that available templates. So here I am using the TypeScript that comes MCP1. It comes with a baked in MCP server, and the thing that I'm mostly interested in showing you here is first index.ts. Yeah, this is a good place to start because it shows the shape of the whole backend. From here, Moose discovered the application by putting the main primitives of the system. I have models, transforms, APIs, all being exported here. You can see models over here, transforms over here, APIs over here. And this brings the idea of analytical backend described as one application. This is basically a good starting point to understand about it. The next thing that I want to show you is model.ts, where you will find that in folder, and this is the place where you define your core model of the backend. I use interface to define your data model. Here I have defined flight snapshot as the raw flight state record. It takes the snapshot ID, origin country, longitude, latitude, right, from the OpenSky API, and I have a few other interfaces as well, like region traffic rollup, flight annotation, watched aircraft, alert rule, generate report. And the key one is here that I want to show you is the ingest pipeline. So which is turning the typed interface, which is turning your typed interface is to a full ingest path. The config is also worth noting here. I am telling the Moose that I want a table, and I'm telling the Moose that I want a table, and I am just specifying order by fields, which means for how the data is organized for OLAP queries. Every data is defined through in MooseStack. Every data is defined through interface first and then Moose primitive. So instead of manually stitching tables together, streams and APIs across different systems, I am just expressing the backend from the code in one place. Now, once the data has been entered, the next question that I want to show you is how to shape it for your analytical queries. So let me open up the bar aggregated.ts from views, and here the data is shaped for analytical. Here the data is shaped for analytics. Up to this point, the system has a working ingest path for the raw flight snapshot, but raw event data is usually not the best shape for queries, and it is not feasible to repeatedly scan every new flight record just to answer questions like how much traffic we see per hour or which countries contributed the most traffic. So here we define the two materialized view, hourly traffic view, materialized view, and the second one is origin country materialized view. And here you see that Moose helps you keep all the transformations and logic inside the application code only. So the next thing that I want to show you is the serving layer for the dashboard. So this is where the APIs for analytical backend that gets out to the dashboard is defined. And let me walk you through the dashboard API, and it has all these tables, and the summary that is being sent to your dashboard is like summary. You have hourly traffic, altitude trend, velocity trend, and the top countries. So this is very interesting to see that the API sits right next to the backend in the code, and in most of the systems, the storage layer and the service layer drift apart. But MooseStack brings you things very closer so that it gets very easy for you to navigate to and work with that. Now the next part is specifically the data has been sent to the dashboard. Now the next part is like how the data gets updated after every interval in the JSON. So I would like to show you the workflow over here, the generator.ts file, and here you basically the data gets fetched from the OpenSky API, and it gets transformed into the flight snapshot interface style, and then it gets posted to your ingested to your flight snapshot. And one more thing is that here runs it just flight data that is scheduled to run every 60 seconds to fetch the flight data from the OpenSky API. So this is like very interesting to see that how MooseStack is bringing together all the pieces, all the broken pieces at one place, improving your developer experience working with the OLAP system. Let me just quickly run the application for you. So if you go to MooseDev, we can run the application from there. And my front end should be running already. So if I go to localhost 3000, you can see all the front end, the whole of your website with all the data. Now I think everything makes sense, like where the air traffic is coming from, where the distribution is coming from. This is coming from the dashboard.ts file where the API is defined and velocity trends and all. So this is all about how you build your OLAP system using MooseStack. Thank you for watching.